In this video, I will review the answers to review for exam number 3. In the first problem, we're given a discrete probability distribution. We have to find the mean, variance, and standard deviation. To find the mean, which is denoted as mu, we multiply each outcome with each probability. So 3 times 0.12 plus 4 times 0.14 plus 5 times 0.29 and so on. After we multiply the probabilities, we add the products together. The mean is 5.2. To calculate the variance, we have to square each outcome. So 3 squared and then multiply the square with the associated probability. So 3 squared times 0.12 plus 4 squared times 0.14 plus 5 squared times 0.29 and so on. At the very end, we have to subtract out the mean squared, so minus 5.2 squared. Don't forget to perform that last operation. When we multiply out, we end up with 28.54 minus 5.2 squared is 27.04. The variance is 1.5. To compute standard deviation, take the square root of the variance to get 1.22. Number 2, we have a problem involving the expected value. 2 dice are tossed one time. You get a sum of 7, you win $10. And we want to know what cost will make the game fair. Well, we construct our probability distribution. We split it into win and loss. In this case, a person can win $10. Their chance of winning, if they play this game, they have to get a sum of 7 when 2 dice are tossed. So that's 6 times out of 36, which reduces to 1/6. The loss is unknown. We'll just call that x, so minus x. So the expected value, we average out the winnings, 10 times 1/6 minus the loss, the unknown loss. So then we have 10 out of 6 minus x. Well, it's saying the game is fair. In order for the game to be fair, the expected value must be 0. So we would set this equation equal to 0, solve for x, and then I'm converting 10/6 into a decimal, so 1.67. So if we solve for x, we get x is 1.67. So $1.67 would be the amount charged, so the game is fair. Anything above this amount is profit for the person who's holding the game. Anything below will favor the player. Number 3, we have another expected value problem. It involves a lottery. If a person buys 1 ticket, they can win $1,000. To win that $1,000, there's 1 chance out of 1,000 tickets that are sold. They could win 500. There's 2 chances out of 1,000 tickets sold. Or they could win $100. There's 10 chances out of 1,000. The cost to play the game is $10. So -10 for the loss. We multiply 1,000 times 1/1,000 plus 500 times 2/1,000 plus 100 times 10/1,000 minus the loss, $10. Well, when we multiply all this out, add it together, we end up with 3 minus 10, which is -7. Thus, the expected value is -$7. That means on average, the house, whoever's putting this game on, is making a profit of around $7 out of each $10 sold, on average. Number 4, we have a binomial probability distribution problem. So for this problem, we have n is 7. We're looking at 7 students, or surveying them. The chance that these students pass Physics 100, 0.69. The chance that a student will not pass it is 1 minus 0.69.31. So using the binomial distribution formula, we need to calculate the probability that exactly 5 pass the class. So the formula is P of 5 is we have 7 students and we're choosing 5 to pass, times the chance of passing is 0.69 and we want 5 to pass, times the chance of not passing is 0.31. Since there's 7 students, 5 are passing, that means 2 will not pass. And keep in mind that these powers will always add up to n. So if one power is increased, the other power is diminished. Let's go ahead and calculate this using a calculator. So we have 7. PRB, I'm going to find my combination function, choose 5, times 0.69 to the 5th, times 0.31 squared. And we get, if we round this to 3 places, 0.316 is the answer. For part B, it's saying at least 5 of them will pass. So at least 5 means 5 or more, so we have to calculate the probability of 5, 6, and 7. We can't go past 7 because we're surveying 7 students, so that's our max. Plug everything into the formula, calculate like we did before. We already calculated P of 5, so that's 0.316. P of 6 is 0.234. P of 7 is 0.074. And then we add all the probabilities together to get the answer for part B, which is 0.624. For part C, it's saying at most 3 of them pass the class. So that means at most 3 means 3 or less. So we have to calculate the probability for 3, 2, 1, 0. We can't go past 0. 0 is the last value that we can calculate the probability for. And performing these computations, for P of 3 we get 0.106, P of 2 we get 0.029, P of 1 it's 0.004, and finally P of 0 is so small we round it to 0. Add up all the probabilities together, so the probability that at most 3 pass the class is 0.139. Number 5 is asking us to find the mean, variance, and standard deviation for a binomial probability distribution. So the key values are n equal to 450, p is equal to 8.1% or 0.081. That's the percentage of people that operate a motorcycle. And then Q is 1 minus 0.081, 0.919. To calculate the mean for a binomial distribution, we just multiply n times p. So 450 times 0.081 means that the average is 36.5. The variance, sigma squared, is n times p times q. So it's 450 times 0.081 times 0.919. And we're rounding to 1 decimal place, 33.5. Standard deviation, we just take the square root of 33.5 to get 5.8 after it's rounded. Number 6 is asking us to use the standard normal distribution to look up the area to the right of negative 0.89. Well, we have to first look up negative 0.89 in table E. Negative 0.89 is 0.1867. That's the area to the left. We want the area to the right, so we take 1 minus 0.1867 to get 0.8133. For number 7, we have to find the area between 2.01 and 3.05. So that means we have to look up both areas, subtract smaller area from larger area. First, let's look up 3.05. .9989, and then let's look up 2.01 and whatever area we get, subtract it from our first area. So for 2.01, 2.00 and 1, 0.9778, we find the difference of these two areas to get 0.0211. Number 8, it says, what's the area under the normal distribution curve to the left of 1.57? In this case, we just have to look up 1.57 to get the answer. So 1.50, 1, 2, 3, 4, 5, 6, 7. 0.9418. Number 9 is saying that we're given an area of 0.3621 between 0 and z, a positive z value, and we have to find this positive z value. So remember, the area to the left is 0.5, so that means we have to find the combined area between 0.5 and 0.3621, because that's the entire area to the left of z. That's 0.8621. Now we look up that area in table E, 0.8621. You have to scan for it, and here it is. 0.8621 is 1.0, and I believe that's 9. For number 10, we're given an application of the normal distribution. They're telling us that the average snowfall is 44 inches in Trafford. So we're allowed to use the normal distribution. So we draw the normal distribution. The mean is 44. And we want to know what's the chance that at most 50 inches of snow will occur. Well, 50 is greater than 44. So we put it over here and we shade to the left. At most 50 means 50 or less. And now we have to convert all these x values to z values. 44 converts to 0. To convert 50, we use our z-score formula. It's 50 minus the mean, 44, divided by standard deviation of 6. 50 minus 44 is 6. 6 divided by 6 is 1. And then we just have to look up 1 in table E, and that's 0.8413. For number 11, similar problem, but now it's saying that the amount of snow is at least 53 inches. So that means we shade to the right and we have to find this area. Once again, we calculate our z value. So 53 minus 44 over standard deviation of 6. 9 over 6 is 1.5. We look up 1.5 to get 0.9332. That's the area to the left, but we want the area to the right, so it's 1 minus 0.9332. The answer is 0.0668. For number 12, we have a cutoff score problem. They give us a top 20%, so we shade the area in the right corner of a normal distribution. It's 0.2. And we have to find this cutoff score. In order to find this cutoff score, we're going to need this z value. So we need the area to the left of this x unknown value. Remember, the mean is 120. So 1 minus 0.2 is 0.8. So now we have to find the area that's closest to 0.8 in our table. So we have to look for the area that is closest to 0.8, and it's going to be this area here, 0.79 995. That's as close as we can get to 0.8. So we look to the left, 0.84. That's our z value. That corresponds to x. Now we calculate the cutoff score. The formula is mu plus z sigma. Mu is 120. Z is 0.84. And sigma, standard deviation, is 25. 0.84 times 25 is 21. 120 plus 21 is 141. That's our minimum score to be in the top 20%. And then finally, for number 13, we have a central limit problem. A key way of knowing that we have a central limit problem is we're typically given some sample. In this case, 25, and then we have to find the probability involving the mean of the sample. So look for that type of wording to indicate that we will be applying the central limit theorem. And remember, we're using what's called a distribution of sample means. It has a normal shape. The mean is 71,180, and we're looking for a sample of 25 to have a mean salary less than 73,000, so we have to find this area. To do so, we have to convert to z values using this formula here. It's x bar 73,000 minus the mean is 71,180 divided by standard deviation of 4362 divided by the square root of 65. And then just keep in mind, this should be an x bar value. I left off the bar, but these are not x values. These are x bar values. Let's go ahead and calculate our z-score value here using a calculator. So I like to use parentheses. We have 73,000 minus 71,180. Close the parentheses, divide, and now for the denominator, which is called the standard error, once we open parentheses, and it's 4362 divided by the square root of 25, and then close the parentheses, select enter, and we get 2.09 as the z value. And then the final step is to look up the z value in table E. 2.09 is 0.9817, and that's going to be the answer. Thanks for watching the video, and good luck on the exam.